The last section of the notes for reviewing exponents is negative exponents. We actually saw this in your 4.1 notes, if you'd like to go back and pull those out. We used this when we were completing tables for graphs of exponential functions. A common mistake that I saw you guys doing was some of you thought because we had a negative exponent that we would have a negative solution, and that's not the case at all. When you have a negative exponent, what happens is you would move it, okay, not make it negative. So if you have something that's in the numerator, like how this is now, you would move it to the denominator. And if it was starting off in the denominator, you would move it up to the numerator. By doing that, you essentially, if you had a fraction raised to a negative exponent, you would flip it. And we're going to see that in this section of the notes now. Starting with a, we have x to the negative 3 power. So again, that negative exponent tells me I'm going to have to move it. Currently, it is in the numerator's position because technically I can rewrite it over 1, just like how I could do 2 as 2 over 1, 3 as 3 over 1, so on and so forth. So I'm going to take my x to the negative 3 and I'm going to move it down to the denominator. So now I have x cubed. The act of moving it makes the exponent positive. Now, in the numerator position, I need to put a placeholder of 1. So my final answer is 1 over x cubed. Let's take a look at part B. What we have here is negative 4, x to the 5th power, y to the negative 2nd power. All of these things are being multiplied together. That negative power only belongs to the base of y. So when I'm asking myself what I have to move, the only thing that's going to move from the numerator to the denominator is the y squared. The negative 4 is understood to be to the 1st power, and then the x is to the 5th power. Both of those are positive, so they're going to stay in the numerator position, leaving me with negative 4x to the 5th over y squared. Now I cannot simplify that any further because these are different bases. Moving on to part C. Now we have multiple terms being multiplied together, being raised to a power. Remember, when we multiply or divide, we can distribute the power. The only time we can't is with addition and subtraction, which I don't see here. So I'm going to distribute the negative 2 to each term. Keep in mind that this is a negative 2 to the 1st power, so it's separate from the x and the y, meaning that I now have negative 2 to the 1 times negative 2, so negative 2 power, and then I have x squared to the negative 2 power, so 2 times negative 2 is x to the negative 4, and then I have y to the negative 4 times negative 2, so that's y to the positive 8. What would be helpful here is recognizing that this whole negative 2 is to the negative 2 power. So that negative 2 belongs to both the negative and the 2. The negative 4 power belongs to the x, and the 8 belongs to the y. So when you ask yourself, okay, what do I need to move? Those would be the terms with the negative exponent. So I need to keep my y to the 8th power in the numerator, that stays, but the negative 2 and the x bases would be moved down. So I have a negative 2 being squared, and I have x to the 4th power. I see a lot of sign mistakes on something like this. Whenever you square a negative number, it becomes positive because negative 2 squared is negative 2 times negative 2, or a positive 4, meaning the final answer is y to the 8th power over 4x to the 4th power. All right, part D, we have division, which means it's okay for us to distribute that power, meaning I have x to the 2 times negative 3 is negative 6. This is understood first power, so 1 times negative 3 is just a negative 3. Both exponents are negative. Remember, that just means we move it. So the x to the negative 6 power is in the numerator, meaning I need to move it down to the denominator, making it x to the positive 6 once I've moved it. The y to the negative 3 is in the denominator, so I need to move it up to the numerator, meaning I have a y cubed in the numerator. I can't simplify any further because they have different bases. Okay, here, I'm multiplying two different things together. Whenever you multiply, we add the exponents, remember? So once again, whenever we multiply, we add the exponents, as long as they have the same base. So when I look here, something that has the same base is x, and then I have a y and a y. So I know I'm going to have x to the negative 2 plus 1 is a negative 1. And y to the 1 plus negative 3 is negative 2. We also have two constants that we need to multiply together. 3 times negative 2 is just a negative 6. This is not our final answer. We need to clean this up by taking care of the negative exponents. The only things that have negative exponents are the x and the y. The negative 6 is to understood first power, so that actually needs to stay in the numerator, and then I would have x and y squared in the denominator. All right, for part F, none of these bases are the same, so I can't combine anything. All I can do is simplify my answer by taking care of the negative exponents. The b cubed is the only positive exponent, so that's the only one that's going to have to stay where it is. Otherwise, I have a to the negative 2, so that's going to move down to the denominator, so a squared. I had c to the negative 4th in the denominator, so that needs to move up to the numerator. So that's c to the 4th power. That d to the negative 1 also needs to move up, so d to the 1st power. Meaning you have 3 terms in the numerator and only 1 in the denominator.